All right, let's look at the solutions for college algebra test on chapter 3. Remember that your actual test is going to look exactly like your sample test. And so when we look at this first question, do the following represent functions or not? Remember that a function has no two x values the same, and the graph passes the vertical line test. All right, so if we look at this first one, you'll notice I have 1, 2, 3. No two x values the same. So yes, that is a function. It does not matter that the y values aren't the same. All right. Then if I look at the next one, 3, 1, and 1, there are two x values the same on that one. So that is not a function. And then for these last two, these are toolkit functions from section 3.2. That means we are supposed to know what those graphs look like. All right, so for the square root of x, that's the graph that looks like this. And so the easiest way to tell if that's a function is to see if it passes a vertical line test. So if I can draw vertical lines and not hit my graph in more than one spot, then yes, it is a function. All right, y equals x cubed. So here's y equals x cubed, another one of those toolkit functions. And again, if I were to draw vertical lines, I would not hit the graph in more than one spot. So yes, that is also a function. All right, then for the second one, they asked me to find f of 4 and f of x plus 4. Now, what is f of 4 asking me to do? It wants me to put 4 in the place of x. All right, so for f of 4, I'm just going to put 4 in the place of x right here. So that means I put 4 in the place of x right here. So 4 squared would be 16, and 16 plus 5 is going to give me 21. All right, then f of x plus 4 means the same thing. Put x plus 4 in the place of x. So if I put x plus 4 in the place of that x right there, that would be x plus 4 squared plus 5. X plus 4 squared literally means x plus 4 times x plus 4. You have to FOIL that out. You can't just square the x and square the 4. So if I FOIL this out, x times x is x squared. X times 4 is 4x, and 4 times x is another 4x. So that's where we get our 8x. And then 4 times 4 is 16, and we still have our plus 5 right there. So 16 plus 5 would give us 21. And so f of x plus 4 would be x squared plus 8x plus 21. All right, number 3 is a piecewise defined function. So when they ask me to find g of -3, I do not plug -3 into both pieces. I look at putting -3 in the place of x. So is -3 greater than or equal to 0? No. Is -3 less than 0? Yes. So that means I use this piece only. All right. So for g of -3, I'm going to use the bottom piece, x plus 4. And then I'm going to put -3 in for x. So put -3 in for x, and that would give me -3 plus 4, or positive 1. All right, then they asked me to find g of 0. So I'm going to come over here and say, is 0 greater than or equal to x? Yeah, I'm sorry, is x greater than or equal to 0? Yes, x equals 0. I couldn't use this down here. 0 is not less than 0. All right, so I'm going to use this top piece, which is 3x minus 1. So you can see for g of x, I'm going to use 3x minus 1, and I'm putting 0 in the place of x. So put 0 in the place of x. So that would be 0 minus 1, or -1. All right, then g of 3. For g of 3, is 3 greater than or equal to 0? Yes. So I'm going to use this top piece right here, 3x minus 1. 3 is not less than 0. I cannot use this bottom piece. All right, so I'm going to use 3x minus 1, and I'm going to put 3 in the place of x. So over here, 3 in the place of x. So that would be 3 times 3 is 9 minus 1 is 8. Now, the graph of a piecewise is your bonus on the test. So you can decide whether you want to mess with this or not. All right, but to begin with, I'm going to graph 3x minus 1. Okay, so however you want to graph a line, You can say my y-intercept is -1 and my slope is 3 over 1. So rise 1, 2, 3, run 1, rise 1, 2, 3, run 1. Maybe you decide that you want to make an XY chart. So if you put 0 in for x, you get -1, and if you put 1 in for x, you get +2, and that would give you 2 points to draw that line, okay? So that is the line 3x minus 1, that whole guy right there. They tell me to keep only the piece of the line where x is greater than or equal to 0. So right here is where x is equal to 0, and the values over here are greater than. So I'm only going to keep the right half of that graph. So I'm going to keep this piece, and I would erase off the other half of the line that would have been down here. Same idea with x plus 4. If I graph x plus 4, like if you put 0 in for x, you get 4. And if you put -4 in for x, you get 0 for y. So those would be our x and y intercepts. So our line would graph like this, okay? So it tells me, though, to only keep the piece that is less than 0. So right here is equal to 0, and all the values over here are less than 0. So I am only going to keep the left-hand side of that line. I would erase off the piece of the line that's up here. And the way that I know whether to use an open dot or a closed dot is because you'll notice that for the line 3x minus 1, I was equal to 0, so I have a closed dot. For x plus 4, for that line, it was less than 0, so that's why I have an open dot. Again, that is your bonus. All right, your domain is going to be all real numbers unless one of two things happens. You either have a fraction or a radical. Every time you have a fraction, you set your denominator not equal to 0. Every time you have a square root or a fourth root, a radical that has an even index, you're going to take what's under the radical and set it greater than or equal to 0. All right, so for this first one, we have a radical with an even index, so we're going to take what's under the radical and set it greater than or equal to 0. All right, so if I solve that, let's subtract 3 from both sides, and then let's divide both sides by 2, and I get x is greater than or equal to -3/2. They're going to ask you to put your answer in interval notation. Be sure that you write your answer this way for me first, because if you get the answer right but your interval notation is incorrect, then I can just take off 1 point. So be sure you write it for me both ways. But for my interval notation, my lowest value is going to be -3/2. And my highest value is going to be infinity because it's going off to infinity. And I'm going to use a bracket with the -3/2 because it's equal to. So remember, when you have an equal to, you use a bracket. If it's just less than or greater than, you use parentheses. And you always use a parenthesis with infinity or negative infinity because you can't equal infinity or negative infinity. All right, then for the next one, we had a fraction. And we said when you have a fraction, you will always set your denominator not equal to 0. So I'm going to set my denominator not equal to 0. All right, so if 2x plus 3 is not equal to 0, let's subtract 3 from both sides, and then let's divide by 2. And so I find out that all real numbers will work except for -3/2. So again, write it that way first. Tell me all real numbers except for -3/2. And then for your interval notation, that's going to be every number from -infinity to +infinity except for -3/2. So the way that we write that is from -infinity up to -3/2. Then we got to skip over that -3/2 and then go from -3/2 on to infinity. Remember, you can't equal the -3/2, so that's why we're using parentheses with it. Now the next one combines those two problems. So normally we would take what's underneath the radical and say what's under the radical is greater than or equal to 0. But since the radical is in our denominator, that denominator cannot equal 0. So that's why we don't have the equal to right there, because it's a combination of both of our problems. All right, so if we solve that one, let's subtract 3 and then divide by 2. And so this is my answer. And to write that in interval notation, my smallest value is -3/2, and then we're going off to infinity, so my largest value would be infinity. And because this is just greater than, I'm going to use a parenthesis instead of a bracket. All right, then for number 5, we want to give the information about our graph. Okay, so to begin with, we want to know where it's increasing and decreasing. When we're giving intervals of increasing and decreasing, you have to give the x values, and you are only going to use parentheses. So x values, and you can see it doesn't matter if we have closed dots or open dots, we're always going to use parentheses for this. Okay, so we start over here, and so over here, this function starts going down. All right, so it goes down from this x value to this x value, because again, we're giving x's, right? So that's from -3 to -2. So it was decreasing from -3 to -2. Then what happens at -2? Well, at -2, it starts going up, and it goes up to this x value. That x value is 0. So from -2 to 0, it's increasing. Then it starts going down again, so it goes down from 0 to this x value. That x value is +2, so decreasing from 0 to 2. And then at 2, it starts going up again, and it increases to this x value, and that x value is +4. So increasing from 2 to 4. For relative maximums and minimums, a relative maximum is where my graph changed from increasing to decreasing. So that would be right here at 0, 2. Endpoints cannot be relative maximums or minimums. They can be absolute, but they cannot be relative. And then relative minimums are where we change from decreasing to increasing. So that'd be right here at -2, -3. And decreasing to increasing right here at 2, -3. All right, your absolute highest value on this whole graph is right there at 4, 4. So remember we said an endpoint can be an absolute. And the absolute lowest value is right here at -3. So at -2, -3, and at +2, -3. That would be my absolute minimum. All right, then for D, we want the domain. Domain of your x values. So I'm going to start over here on the left, and the very first x value that I come to is -3. Now, because that's an open dot right there, I'm going to use a parenthesis with my -3. And then I'm going to keep going. The very last x value that I have is right here. That's at +4, and there's a closed dot there, so I'm going to use a bracket there. The thing that we only use parentheses with is the increasing, decreasing, okay? So when we're giving interval notation for our domain and range, then we're going to use our brackets and parentheses based on the open dots and the closed dots. All right, so we had a closed dot at 4, so that's why we used a bracket there. All right, then range are our y values. So we're going to start right here at our bottom, and we're going to work our way up. All right, so if we start at the bottom, the very first y value we come to is right here at -3. And as we go on up, the very last y value that we come to is right here at +4. So our range is going to be from -3 to +4, and there are no holes in the graph at -3, so I'm equal to that, so bracket, and of course closed dot here, so a bracket with the 4 as well. All right, then E asked me to find f of 0. So that tells me to put 0 in for x and see what I get for y. So let's come down here to the graph. When x is equal to 0, my y value is 2. That would be the ordered pair, 0, 2 right there, right? So when x is equal to 0, my y value is 2. And then they asked me, is this a function? All right, if it's a function, then it has to pass the vertical line test. So that means I can draw vertical lines and not hit my graph in more than one spot. So yes, it is a function. Then they asked me, is it a one-to-one function? So for it to be one-to-one, it has to pass both the vertical and the horizontal. So I'm going to do a horizontal line test, and you can see I hit my graph in more than one spot. So it is not one-to-one. So it is a function because it passes the vertical line test. It is not a one-to-one function because it does not pass the horizontal line test.